All right, today we're going to be talking about 1.4 beginning proofs, and specifically we're going to be dealing with two-column proofs today. So our learning target is I can write two-column proofs about segments and angles. That will be our end goal. Again, today we're just focusing on segments, but more so than that, I'll see a lot of angles today. So getting started, we're going to start with a congruency problem. So we have angle ABC is congruent to angle GEF, and we want to find the measure of angle ABC. So first off, we know that these are congruent, and we know that congruency means that we can set these angles equal to each other, since they're the same. So these two angles are the same amount. So this will give us 2x plus 5 is equal to x plus 45. From here, we just need to solve for x, because once I have x, then I can find the measure of angle ABC. So to do that, we go ahead and we subtract an x from both sides, which will give us x plus 5 equals 45. From here, I can subtract 5 from both sides. 5s will cancel out on the left. This will leave us with x equals 40. Now at this point, now that I know what x is, I can go ahead and I can plug it back in and solve for our missing angle. Now it doesn't matter which angle I plug it in for, ABC or GEF. Well no, since they're congruent, they're the same angle. And since they're the same, it won't matter if I plug it into either angle because it'll give me the same answer. So if I take this 40, and I plug it back in for angle ABC, well, this will give me 2 times 40 plus 5. Well, 2 times 40 plus 5, that will give me 80 plus 5, which is 85 degrees. So the measure of angle ABC is 85 degrees. Now, if I plug that 40 in for our other angle, I should get the same answer. So 40 plus 45 will give me 85 degrees as well. So again, it doesn't matter which one you plugged it back into because they're congruent, so you should get the same answer regardless. All right, so today's topic will be a bit more difficult to understand than previous topics at first. So if you need to ask any questions, leave them in the comments or just send me a quick email. I'll be happy to help you guys out as much as I can with this. These proofs will show up throughout the entire year, so make sure that you keep that in mind as we go through them. That way you're not caught off guard by them. So, first off, we have our definition of theorems. A theorem is a mathematical statement that can be proven. This is a very big topic within mathematics, and as you go higher and higher in mathematics, you're going to see a lot more theorems as you go through those courses. So what this does is it'll take logical steps based upon given information. So each problem will give us some information, and each time the given information will change. And with that given information, we'll need to prove the statement that they would like us to prove. Now, these proofs will lead to shortcuts that we can use in mathematics later on, and they'll also lead us to some rules that we can follow that will work every single time, which will help us out with those shortcuts as well. So these will be very useful for us as we continue. Now, when completing a proof, your first step should always be to write what was given in the problem. So the first thing that we need to do is write out what's given to us. As we do that, we should also draw pictures or draw on our pictures that are given to us as well. This will help us organize our work. From there, we're going to build upon our previous statements, and again, we're going to stay in the statements column. So we're going to build upon our previous statements using our logic, and our reasoning is going to come from definitions, from vocabulary, from various things that we've learned throughout the course. And our reasoning needs to be logical, and it needs to build upon that statement. So, here's our first proof. If two angles are right angles, then they are congruent. So, given angle A is a right angle, and angle B is a right angle, we need to prove that angle A is congruent to angle B. So we first start off with a picture. So I drew my picture. I have angle A here and angle B here. They tell me that they're right angles, so I went ahead and I drew a box in each. Now from here, my first statement should be what's given to me. Angle A is a right angle. And the reason I can say that is it's given. After that, number 2 should also be the same exact thing. So for number 2, angle B is a right angle, my second given information. So angle B is a right angle. From here, we can continue on. What does it mean to be a right angle? Well, if an angle is a right angle, that means that it needs to be a specific measurement. And that measurement is 90 degrees. So we should say angle A is 90 degrees. Well, why can I say that? Well, if an angle is a right angle, then it's 90 degrees. That's the definition of a right angle. So I can go ahead and put that. If an angle is a right angle, then the measure is 90 degrees. And what we see here is a conditional statement. It says if and then. So if we know it's a right angle, then it's causing it to be 90 degrees. So this conditional statement, the first part is going to use my previous statement. The second part is going to use what leads me to what I can say with this next statement here. So again, it's building upon itself. It's building upon what we know of right angles. Now, if that's true, could I use the same information for angle B? Absolutely. So for number 4, I can say angle B is 90 degrees. And my reasoning is the same exact thing as the one before it. So I can just put same as 3, or I can write out this whole thing once again. It's up to you on that point. Lastly, we know that both these angles are 90 degrees. So can I say that they're congruent? Well, yes, congruency means the same, and if they're both 90 degrees, that means that they're the same measurement, right? So I can say angle A is congruent to angle B, and the reason I can say that is because they're the same measure. Like, what is the definition of congruency? Two things that have the same measurement. So in this case, I can write if two angles have the same measure, then they are congruent. And that's the end of our proof. Now, whenever I'm done with a proof, at the very top, I'm going to put a little black box here. That black box is to tell me that I'm done with my proof, so that if I need to go back and work on my proofs more, that I know that I'm done with this one. And it also tells whoever's reading through your proofs that you are finished with that proof and that it's ready to be checked as well. All right, next up, we're going to do the same exact thing, yet this time we're going to be dealing with straight angles. So if you need to pause the video here, go ahead and pause the video, try this one out on your own. All right, so for this one, given angle ABC is a straight angle and angle DEF is a straight angle, we want to prove that ABC is congruent to angle DEF. So again, we start off by drawing a picture. Have angle ABC and angle DEF here. At this point, I can go ahead and write my given statements. So my first given statement is angle ABC is a straight angle. That's given to us. Can also say angle DEF is a straight angle. That's also given to us. So I just wrote out both of our givens to begin. Now, straight angles. What do we know about straight angles? Well, we know straight angles straight angles are 180 degrees total in that straight line. So there's 180 degrees in this angle. So I can go ahead and say angle ABC is equal to 180 degrees. And how do I know that? Well, if an angle is a straight angle, which they tell us it is, by definition, that angle should be 180 degrees. So I can go ahead and say, if an angle is a straight angle, then its measure is 180 degrees. And again, we see a conditional statement here. If I know the angle is a straight angle, then I can say it's 180 degrees. So I'm using information from previous statements in my if portion, and then for my then portion, I'm using information that I said in my current statement. Can I use the same logic for angle DEF? Absolutely, we can reuse statements and reasons. So I can say angle DEF is 180 degrees for the same exact reason as number 3. Then if we think back to our first theorem that we just proved, we can use that same logic once again. So I know that they're both equal to 180 degrees, so can I say that they're congruent? Absolutely. So we can go ahead and say angle ABC is congruent to angle DEF, and our reasoning is, well, we know that they're both equal to the same measurement. So if I know that they're both equal to the same measurement, that's working from previous statements, so that's my if portion. Then I can say that they're congruent. So if two angles are the same measurement, then they are congruent. So again, using previous information to tell me about my current statement. At this point, we have now proven our proven statement. So we are finished with this proof, and we can draw our box. All right. Now, these first two proofs that we just did, these are leading to shortcuts for right angles and straight angles, as well as congruency. So anytime that they give me two right angles now, I can automatically, without going through all that information, I can say that they're congruent to each other. Same with straight angles now. If I see two straight angles, I can right away say that those two angles are congruent. I don't need to say that they're 90 degrees and go through that whole process now. We know that they're congruent, because we just proved it in this slide. So here is another one, and we're going to use our shortcut here. So go ahead and pause the video if you need to, try it out, and then we'll work on it together. Okay, so the first thing that we need to do is write our given information. So angle A is a right angle, and angle C is a right angle. I went ahead and I drew them in already, but we need to write them out as well. So angle A is a right angle C is a right angle. Those are both given. Now, what does it mean to be a right angle? Well, it means to be 90 degrees. We know that for certain. So I can go ahead, and from our previous slides, we know that if two angles are right angles, they're congruent to each other. So I can skip ahead and say angle A is congruent to angle C, because we know all right angles are congruent. So my reasoning will be, if two angles are right angles, then they are congruent. So if two angles are right angles, then they are congruent. And again, we see a conditional occurring. If, then. So that's occurring right there. At this point, we have proven our statement that we are looking for. Angle A is congruent to angle C. So our proof is now finished. So just a quick reminder when you're going through your proofs, make sure that you're drawing in parts of your proof as you go. And have scratch paper handy. You're going to make mistakes on this. Having that scratch paper handy will be useful because you could just strike out what you messed up on, and that way you know not to mess up with that once again. So I encourage you guys to have scratch paper ready, and then also draw as you go. So here's our next one. Go ahead and pause the video if you'd like. Try this one out on your own or until you get stuck, and then you can work on it with me together. So in this problem, we have a diagram as shown. So we have this diagram here. We want to prove that angle EFG is congruent to angle HFJ. So once again, we start with our given information, and our given information is diagram as shown. So from a diagram, what can we assume? Well, if we are not sure, we can check from unit 1.3 notes. I have them right here for you, so you can check right here. And these are all the things that we can assume from a diagram. Right here, I can see that we can assume straight lines and angles. So I see that we have straight lines here, so that must mean that there's straight angles as well. So I can say, for my first statement, diagram is shown. That's what they give me. They just give me this diagram. At that point, we can go ahead and talk about the angles. So what can I assume from this diagram here? Well, I can assume that we have straight angles. I can assume that angle EFG and HFJ are straight angles. Again, that's one of the few things that we can assume from a diagram. So that's my reasoning. It's one of the few things that we can assume from a diagram, so we just write that. Now, if they're both straight angles, can we use a shortcut now? Well, absolutely we can use a shortcut. We can jump straight to our proven statement. Angle EFG is congruent to angle HFJ. Now, why can we use that? Well, in Theorem 2 that we proved earlier today, we found out that all straight angles are congruent to each other. So if two angles are straight angles, then they are congruent. So if two angles are straight angles, then they are congruent. From there, our proof is now finished. We can move on. Go ahead and pause the video if you'd like. Work on this one on your own for a second, and then we'll jump into it. All right, so for this one, we're given information. Angle RST is equal to 50 degrees. Angle TSV is equal to 40 degrees, and angle X is equal to 90. So I can draw this all in my picture right away, and I can write that all as my given. And this time I went ahead and put it all in one line, and that's completely fine. You can do that as well if you'd like. It'll save you some space with writing given multiple times and taking up multiple lines. Now I also drew this on the picture already. I'll go ahead and write my 90 degrees here. And once we have all of our given statements written down, we should look at what we're trying to prove. So we're trying to prove angle RSV, this angle here, is equal to angle X. Now I already know that angle X is equal to 90 degrees. So what can I do over here? What can I do with this angle on the left? Well, what if I added these two angles together? Because again, I know that this angle is 90. I need to prove that this angle is 90. So what's 50 plus 40? Well, that's 90. So I can say angle RSV is equal to 90 degrees. Why? Because I added these angles together, and that, if we recall back from early on in this class, that's called the angle addition postulate. 50 degrees plus 40 degrees is equal to 90 degrees. That's where it came from. At this point, can we finish up the proof? Well, we know that angle X is 90. We know that angle RSV is 90. They're the same angle measurement, so are they congruent? Absolutely. So I can say angle RSV is congruent to angle X, because if two angles are the same measure, then they are congruent. You may be wondering, well, couldn't I say that they're both right angles? I could, but it doesn't talk about right angles prior to this. So if I see that they're the same measure, they don't talk about right angles, I can just say, oh, well, they're the same measurement, so they're congruent. That is the end of this proof, so we can go ahead and finish up with our box at the top. Now, just a quick reminder for you guys, proofs can be done in multiple ways. No one's proofs are going to be the exact same proofs as anyone else's. They may have little slight differences here and there. They are like writing, so you will develop your own style as you go. And probably one of the most important things that you'll learn in this class, just because of the logical thinking that will come with this. Because again, you need to have that logic there in order to create these things. Your proofs will almost never look the same as anyone else's proofs, especially when we go into paragraph proofs, because then you're just writing, and it is your own writing, of course. So, here is another way to do the proof that we just did. As you can see, I took more steps here, so I said that it's 90 degrees and then called it a right angle. And then at the end, I could say that all right angles are congruent because I brought in right angles here. But again, you don't need to do that if you see that they're the same measurement, and you can say that they're congruent because they're the same measurement, of course. But just so that you can see that there are multiple ways, and sometimes you won't have it written the same way as anyone else. So just keep that in mind. All right, our final proof for today is this angle right here. We know that the measure of angle MBA is 84 degrees, angle ABO is 42 degrees, and we want to prove MBO is congruent to ABO. So once again, we're going to go ahead and start off with our given information. We're going to draw that in. So I draw in my given information, 84 degrees for the whole thing, 42 degrees for this bottom angle. I can go ahead and write my given statements as well. So I go ahead and write MBA is equal to 84, ABO is 42. Those are both given to us. Now at this point, how can we find the measure of angle MBO, this angle here? Well, I have the full thing and I have this bottom part. I just want the top part. So what if I take the full angle and I subtract this 42 degrees from it? Well, we can absolutely do that. So we can say the measure of MBO is equal to 42. And the way that we got that is we did 84 minus 42. What postulate is that called? Well, you can write this two ways. I can say it's the angle subtraction postulate, or I can say it's the inverse of the angle addition postulate. Because instead of addition, I'm using subtraction, so it'd be the inverse of addition. Either one works. I'm fine with if you use subtraction. I'm fine if you use inverse of addition. Either one works. And again, here's where we got the angle from. So 84 minus 42 will equal our missing angle. At this point, we know that ABO is 42, MBO is 42. Can we finish this off and say that they are congruent to each other? Absolutely. So angle MBO is congruent to angle ABO. And what makes them congruent? Well, they have the same measurement. So if two angles have the same measurement, then those angles are congruent. And again, we see an if-then statement here, a conditional statement. With that, our proof is now finished. The homework 1.4 is in Schoology for you guys if you need it. And of course, if you have any questions, please let me know. Thank you guys for stopping in and watching today. I hope that you guys have a great rest of your day. Thank you.